All right, so today is a review and example lecture. We're going to go over a lot of LO1 topics, and this is mostly open-ended. Those of you watching on YouTube, I will be interacting with chat a bit through this lecture, so whatever the class wants to see, I'll kind of be reacting to that. I also have some prepared examples, some things that I definitely want to go over, and with that, let's just dive into some things, some code and stuff. I'll spend a lot of time in IntelliJ, possibly the entire lecture in IntelliJ today. So let me rearrange windows a little bit. We want dog. Hi, YouTube. YouTube, thy muffin man says hi. Just so y'all know. We want dog. I don't think the dog's even up here right now. All right, so let's go over some of these examples. These are some examples that are in the repo. This subtract method we went over in the slides on Wednesday, and we can go over this briefly in the code again. I do want to show one thing with this, and we can see some of these other examples. The is negative method, as some of you asked where that is up here. We can go through this one as well. And these examples are designed, these were designed, and still are, I guess, but they were designed with the intent of preparing you for lab. So if you went through all these examples before lab, studied them, realized, what X is going to be in scope at what time, things like that, you were well prepared for that lab. So that's why I made these examples and went over one of them before lab. So while I go through this example, we want to talk about what's happening on the stack, and I'll kind of walk through that. But I also want to run the debugger. So we saw the debugger very briefly on Wednesday. That's something that I want to emphasize in more and more lectures as we go throughout the semester. So we'll get dog during that spring break. Yeah, that's probably true. A little more dog time. So let's set this to actually call, and let's subtract 5 minus 3, which I believe is the exact input that I used for lecture, if I'm not mistaken. So I want to trace through the execution of this program, but instead of me just explaining through it, what I'm going to do is set a breakpoint, which is going to allow me to run the debugger, which lets me run through my code line by line. So I set this breakpoint. I'll set it for our purposes here at the first line of main and run the debugger. What this is going to do, what the debugger does, is runs through my code until it hits a breakpoint. To set a breakpoint, we click in what we call the gutter over here. That sets a breakpoint. I can have multiple breakpoints. I can remove breakpoints, add breakpoints. But what the debugger is going to do, once it gets done compiling here, is run my code until it hits a breakpoint and then stops everything. So it ran, it hit the very first line, hit my breakpoint, saw my breakpoint, and stopped. When it stops, it's going to show me everything that's in memory at that time. It's going to show me all of the stack, what's going on with that. The stack frames we can see over on the left, and all the variables that are currently in scope over here on the right. So every variable that's in scope, right now that's only args. The breakpoint is before the line executes. So this line val x of type int equals 5 has not executed yet. This is very helpful. They call it a debugger for a reason. When you have bugs, this makes it a lot easier to find those bugs and get rid of them. Run the debugger. This is something that we'll stress in office hours as well. The two big things myself and any TA should be asking in office hours when you have a question, especially now that we're rolling with the semester a bit more, is, okay, you have a problem with your code, show me your test cases, and show me the debugger. What's happening in the debugger? And I can just about guarantee this. If you run the debugger through your code before coming to office hours or before posting on Piazza, you probably won't have to come to office hours or post on Piazza. You're going to see your answers because you're going to see all of what's happening on the stack. If you run the debugger and you can't, come to office hours, post on Piazza, let us know. So now that I have the debugger running and execution has stopped right here, On the highlighted line, some of this terminology you can see in your quiz, I'll have a highlighted line and tell you what's going on right here. What's the state of the stack? What I effectively mean is you be the debugger. There's a breakpoint on this line. What happens when you hit that breakpoint? What's the state of the stack? So at this breakpoint, the state of the stack is pretty boring. I have the main stack frame on the stack, and I have args as the only variable. So now let's start clicking this step into button. And this is going to step through my code one line at a time. So let's step through, go right to the next line. So this line, val x of type int equals 5, has executed. And I see right on my variables, just as we expect, on the stack is a variable named x with a value 5. Just like we saw in lecture when I had this in the slides, this is the same information that we're seeing here. We're seeing a variable get added to the stack, and we can see that it's currently in scope. Step again, y is going on the stack, assigned a value 3, and we can see that value, it's in scope, I can see it in this stack frame. We have 2 variables on the stack. Go us, we are chugging along through this program. The next line, we have a bit more work to do. We hit a method call. When we hit a method call, and this is one of the big interview questions, when we hit a method call, we're going to put a new stack on, a new frame on the stack. And I saw in the interviews yesterday, a lot of you getting stack memory confused with stack frame. Stack memory is the entirety of everything where all our variables are stored for this program until we start talking about heap next week. That's where everything is stored, is in the stack memory, which is a chunk of our RAM stick in our computer. A stack frame is created when we call a method, and the stack frame is added to the stack. And I use stack and stack memory interchangeably, or memory stack. I'll use those interchangeably sometimes. But the stack frame is added to the stack. So when we step into, we're going to go into that method call. We're stepping one line forward. And we can see that we've created a new frame on the stack for this method call of subtract. And in this frame, we have an x with the value 5 from our parameter, and we have a y of value 3 from our parameter list. So our parameters are put on the stack, and we can go down to the next stack frame. We can see all of the frames that are on our stack, which are pictorially upside down from the way I showed it in lecture. But this is the current running frame, and I can still visit my main stack frame, and I can see the variables that exist here. We have args, we have x, we have y, and this x and y, even though they have the same values, are different variables than the x and y in this stack frame for the method call of subtract. To run the debugger, I set a breakpoint. The question in chat, I set a breakpoint by clicking over in the side. And then you can't see the drop-down menu, but when I click this, I'll click the bug icon. Or if you're debugging the previous thing that you ran, say I just run this using our go button. Oops, I think I just stopped the debugger. Using the go button, then it will be the last thing that you've executed. And then at that point, you can hit the debug button right here. In the drop-down menu, the debug button will look the same here, this little bug icon. So let me step through to get to where we were. And we can continue stepping. We're going to create a variable z. We're going to look up a value for x. X resolves to 5 in this current scope. And we have a variable z on the stack of value 5. It even marks these are p for parameters. This is a local variable, which I should probably use the terminology more. This is a local variable, which means it has scope local to this method. Do I ignore all the formula stuff for Habersign? Yeah, if you mean the stuff above the JavaScript code, you can safely ignore that. This isn't a math, this isn't a trigonometry class, so I don't expect you to, there's no expectation that you have to understand that for that question. So now that we're at this line, we're going to step into again. And when I do step into, this is named step into because it's going to advance one line of execution and also step into any method calls. So we stepped into the subtract method. And if we, we want this resized. And when we step into right here, we're going to step into one of these methods. We should, if I'm right here, we should step into the absolute value, but the nice thing about doing a live demo is IntelliJ is going to tell us exactly the answer. So I'm going to step into, it's going to give me a pop-up. I'm going to step into again. Oh my goodness. You know, I was worried about this. The debugger sometimes will skip some things like it did just here. Skipped right to the end of the method to z equals 2. Let me, this is the problem with live demos too. Choose a method to step into with the arrow keys. Oh my. So IntelliJ doesn't even know what method to step into. So I chose the absolute value method. Live debugging the debugger. Yeah, we're in the thick of it now. There's no going back at this point. I'm committed. So now we call the absolute value method, and we can see we have a new frame on the stack. And for your quizzes, it's fine if you don't have these internal stack frames. But we do get a stack frame for the call to absolute value, which is part of the the Java math library. So we have absolute value. It does what you would expect it to do with syntax that you're probably not familiar with. This is a ternary function or a ternary statement where it's effectively a flattened out conditional. It's saying if this, then this, else this. So it's a flattened out if-else statement. So if A is less than 0, return negative A, else return A. That's good. That's what we want our absolute value method doing. Takes the absolute value of A, and that returns. And now we can evaluate until, which should give me another choice here, apparently. Until is not going to give us any real code. Gets into more stuff that deep in a library that we don't care about. What actually is this? I don't even know what this is doing. So whenever you get this, which you will get when you run the debugger, obviously I'm getting it right now. This is expected stuff that this is going to happen. We're getting several layers deep into a library that we don't really care about. So when this happens, we have this step out button. What are we doing now? I'm showing off the debugger, but really we're going over, we're reviewing stack memory. So the debugger is showing us everything that's going on in the stack. But there are inevitably things like this right now where I just got to show you tips and tricks about how to use the debugger effectively. So I'm going to use the step out button. That's saying, look, I found myself in a place that I don't really care about. I'm convinced that this code is correct. We're deep into the until method. This is the until stack frame, which called multiple other methods and put more frames on the stack. So I'm going to click this step out button, which is going to take me out of the current stack frame. It's going to take me to where this stack frame was called and created and resume execution at that point. So I'm going to get out of this stack frame, get out of this stack frame, get out of this stack frame. I think it's thinking. Get out of that stack frame, get out of the until stack frame, and get back to my code. Now, we got a little lost there, which will happen. I did want to show that one was intentional. Where we kind of got lost in a library with that until call, and we got out of that and back to our own code. Now that we're back in our own code, we can use step into again, and hopefully advance a line. So I don't know why it wants to skip over my for loop. So another useful tip, I'm just going to set another breakpoint. I'm going to rerun the debugger. It's going to stop at the main method at this breakpoint. Now, I'm not really concerned with the main method at this point. We're in too deep to abort, that's correct. So I don't really care about the main method right here. because we already went through this. We know X and Y get put on the stack. We create a new stack frame. We assign the parameters to the arguments. So I'm going to click the resume button. And this is going to resume running the program normally until it hits another breakpoint. So when I click this, it's going to run until it hits my second breakpoint. And now I can get inside that loop and take a look at what's happening here, which is our X and Y as we expect. Actually it executed that line. So our Y, like we expect, our Z, like we expect, that is assigned to X. Our I for our loop, which is currently 0, because this is the first iteration of the loop. And X, which is going to equal, X, which is going to equal 5. So everything that we expect. I don't know why I got tripped up on that one. So let's step into one time here and run this val x of type int equals 20 line. Now we have a value, technically in this case, named x with the value 20. And now since we created this value with the same name as a variable that was already in scope, that effectively covers up the other value of x. This is a big thing that I tested on your quiz, something we've talked about the past couple of days, and especially on Wednesday. We can see this in the debugger now. We can have multiple variables or values with the same name in the same method as long as they're in different code blocks. So inside this for block here, inside this code block, we created a value named x, and that hides this value of x. So the x that's currently visible on the stack, which we call in scope, the variable that's currently in scope named x, is this x equals 20 right here, this value of x named 20. Whenever you use val or var, you're creating a new value that's going on the stack, a new variable with a new name that's going on the stack. So we created a new value named x, assigned it the value 20, and put that on the stack. So now when we use the value x, if we use the value x right now, x is going to be 20 and not 5 like this x is. This x's value is 5, but since that's not in scope, we can't see that. But one step ago, before we executed this line, if we used x right before that, actually we can just do this. Print line x. That x is going to be this x right here. And then if we print line x right here, that's going to say illegal forward reference, isn't it? This x right here is going to be this x that we're declaring right here. Does that? I just want to verify that that's going to say illegal forward reference. I think that's the error that I'm going to get. Scala's not going to like me doing that. Wrong forward reference. So I can't even do that. If I delete this, then that's going to work. But since Scala's looking ahead and seeing that I'm going to declare an x and that it's going to think that I'm using an x before declaring it, the compiler's not looking for my other x that's currently in scope at that point. So I actually don't get away with that one. But deleting this, I can access this x, but as soon as I create a new variable named x in this block, then this x is going to cover up this x. So let me set my breakpoint again. Run the debugger. Until is a method call. If you don't think of it as a method call, that's fine. But until actually is a method call. That's why we got several frames deep. Until will put a new frame on the stack. We're just using some Scala, what we call syntactical sugar, just some fancy stuff. But this is a method call. So this x is going to cover up. Right now x is equal to 5, but that new x is going to cover that up. Now this is the x that's in scope. We have two x's on the stack. Where did my... I don't want build output. I want terminal. So I do have in the main method an X, in this method an X parameter, and an X. I don't want to go in there yet. And an X that was declared inside the block for the for loop. Let me get back where I was. And as soon as we call this line, that X is going to be 20. So we have 3 variables named X on the stack. Only one of them can be in scope at a time. I have this X, which is in scope. This X, which is out of scope, but in the same stack frame. So once this X is out of scope, this X will be in scope again, and we'll be able to access it again. The X in the main frame, we cannot access from this frame. You cannot access variables in a different stack frame. So method calls cannot access each other's values across those stack frames. The difference between until and to, until does not include the endpoint, and to does include the endpoint, is the only difference there. So this, I'm not including y itself. So I'm going from 0 to y minus 1. If I replace this with 2, I would go from 0 to y. So 0 until we reach y, or 0 to y is some of the terminology there. So now we can step into again. If I'm not concerned, I'll do this both ways. If I'm not concerned about the is negative method, which I'm going to do first, I want to skip over this method call. I know a new frame is about to be added to the stack, and I'm just not concerned about it. I can skip over it with this step over button. And I'd say these are the 3 buttons I use the most: step over, step into, and step out. With those 3 buttons, you can do a lot of stuff with the debugger. The debugger is a very powerful tool. It has many more features that I won't talk about, that I honestly don't really use that much. But I will show you these 3 buttons. Step over is going to skip over the is negative stack frame. So I'm going to skip over that. We know that's going to return false because y is positive. And we get into the else block. In the else block, currently, this X with the value 20 is in scope. Once I step one line ahead, I create another value named X and assign it the value 1, and that's going to be the X that's currently in scope. So now I have 4 variables, all of type X. Some of them are actually values, but I'll use those interchangeably sometimes too in the context of stack memory. I have 4 variables named X. 3 of them are in this stack frame, but only the one in the innermost scope is going to be accessible. So I'm currently in this block. When I try to use a variable named X, it's going to find this one because this is the closest one that we can find. If this was like X1, let me have a better name for that. This is like ZZ. Now, this is the value of X that's currently in scope. If I rerun the debugger and get back to that spot with a ZZ, remove my breakpoint in main, now X is going to be 20 because we're going to see this X. That is the X that's currently in scope because it's the innermost one that we can see. If this one, no, XZ, if this is not named X either, we're going all the way back to this X. This is the X that's going to be in scope. And now we see that X is equal to 5 at this point, and we have these extra variables on the stack. But since these are all named X, they end up covering each other up. And this is the X that's currently in scope. So when we do Z minus equals X, Z is 5. Didn't find Z in this block, but we did find Z up here. That's the one that's in scope. And X, we found X right here, so we don't even look for the other 2 X's. We never get to find those. So this is the X that's in scope, and we get Z equals 5 minus 1, just 4. And then we keep going through this loop. Oops, I didn't mean to do that so fast. Let me restart this. So now let's go through this loop again. I increments to 1. Our Z is currently 4. And this time, instead of stepping over is negative, I want to step into is negative. Say this time I want to debug is negative. I think that's where some of my errors are coming from. Not that, I mean, this code works fine. But let's step into and see what's happening with that is negative. So I'm going to step into this, and it's going to take me to the is negative code. I'm going to get the parameter on the stack with whatever argument it was called with. And I can see the stack here, this is negative call, which is currently executing right here, is on the stack. We get some extra stuff here, some extra anonymous functions that are being called. This is some internal functionality like this, the for each method. That's part of our loop, our for each loop. The apply method is not 100% sure where that one's coming from. The subtract anonymous method. But if you look for the next method with the name of one of your methods, that's the next stack frame that we're concerned about, that we have to think about. This subtract method is currently executing on line, because of all the internals, on line 40. So it's inside the loop, which is actually on line 42, calling is negative. And we can see all those variables still. And we can still go all the way back to the mainframe. Mainframe is sitting on line 84, waiting for the subtract call. This subtract call to resolve for that frame to end and return its value. So we can look at the entire state of the stack across all of the stack frames and all of the variables in each stack frame. And of course, in lecture, I would show each stack frame all consecutively and then separate them by this is the start of this stack frame. But these are completely separate environments with their own variables, and they cannot access each other's variables. And we can step through the is negative. X is less than 0. I'm going to create a var y. This is one of the kind of a trick question a little bit. I have a var y. I'm setting that equal to false. And in fact, that's what I want to return. X is not less than 0. So I want to return false in this case. I create a new variable named y and assign it to true. And then I immediately hit the end of that block. This variable is destroyed because we hit the end of the block. And y is going to be false in this case. Even though we set a variable named y to true, y is going to be false because we hit the end of a block. Whenever we hit the end of a block, all of the variables declared within that block are destroyed. So since we say var y equals true, that's destroyed. On the opposite side, if x is negative, here we set a variable named y equal to true, but we don't declare a new variable. If we said var y equals true, this method is broken and doesn't work because we created a new variable named y, and then that gets destroyed when we hit the end of the block. Since we just say y equals true, we're not declaring a new variable named y. We're using the existing y that's in scope and reassigning it the value true. So this line doesn't do anything. This has no effect on our program at all. This line does because we didn't redeclare a variable named y. Then we return y. This stack frame is going to be destroyed and give its value back to this method. So this method gets to continue. It gets its value of false, and we do the same old dance that we've done before. We're going to iterate until y minus 1. Y is 3, so I is 2. So this is going to be the last iteration of this loop. We go into is negative again. I don't want to go through is negative again, so I'm going to step out of it. And we get to the end of our loop, which when we get to the end of the loop, all the variables that were declared inside the loop, including this x and this I, are all destroyed. They no longer exist. And now x is going to revert back to this x because that's the only x left. It's the innermost scope x, but it's also the only x that's left. It's the only x that exists anymore inside this stack frame. So now x is back to being 5, not 20, not 1. It's still 5 because this variable is still there the entire time throughout the entire execution of that loop. But but it's now back in scope, and x can be 5 again. We don't actually use that x, but that is the x. If we had print line x right here, that's going to print out 5, because that's the value of x at the moment. And then we're going to return z, which is 2. This stack frame is destroyed, along with all those variables. All those variables, gone. Back to the main stack frame, where x was 5 and y was 3. Create a z. That's going to get the return value of this stack frame, which is 2. And we just print it to the screen, because we're not doing anything fun. At any point during the debugging process, you can flip over to this console tab and see what was printed to the screen, and we can see that our 2 was printed to the screen. And I didn't watch all of chat there. I should have been watching closer, but kind of got caught up in that. So if you want to see any of that again, I'll catch up on some chat messages. If you want to see any, let me know. Oh, and let me see if anybody's actually using the thing. Ooh, yeah. Oh, you're just listing all of it. Yeah, we did. So we just did these 3. Unit testing and truncation error. You could have just said go over LO1. That's everything. Except you could have added testing lists too. You would have got everything at all. Everything entirely. It's up repetition. And these other ones we already read. So maybe that's, let me try refreshing just in case it's not taking votes. But if not, it looks like y'all don't want to use the suggestion box, which is fine. Thought I'd try a new tool. Oh, there's voting. I have to. There wasn't on the new ones though. Did those already get? I just didn't scroll down and see those. Regardless, I think that's a failed experiment. If y'all don't want to use the suggestion box, that's fine. We just won't use it. And when I do Piazza stuff like that to get suggestions of what to cover, I don't get much either. So I was trying something different, hoping to get more interaction, but skipping headers. Yeah, skipping headers is a great debugger problem. Run the debugger and see exactly, you'll see exactly what's happening. You get to the header line, you'll see line, the variable named line equals, and you'll see the header string, and then you'll get to your conditional, and you'll see that, well, that's the input of my conditional, and this is what my conditional does. And then things break, you can really deduce from there what's happening. So stack frames we don't know are just anonymous background functions. So those are internal to Scala, those anonymous ones. And that's just the way, and that's part of the way that Scala handles this loop, the for loop. After it goes through the compiler, this turns into a couple method calls of anonymous functions. So not to completely blow this apart, but this, after it's compiled, actually turns into this. I don't even use I, do I? For each. Actually turns into this, which is a method call to the for each method. Loops are kind of an illusion. The way we use them, the syntax we use, it's compiled down to a method call to a for each method, which takes an anonymous function. So what you're seeing is the for each stack frame and the anonymous function stack frame. Those were those two that I said just don't worry about it. And I'll still say that. Don't worry about it. You don't really have to know about this. You don't have to think about this. We will talk about for each and anonymous functions when we get to functional programming, but we still don't need to be concerned about how they behave on the stack, much less how the compiler treats loops and compiles them down to something else, and then how that's how that goes on the stack. Right, so if we declare a variable in a code block and never use it, then it's destroyed at the end of the code block. It has no effect at all. And that was question 1 on the quiz. I had that if statement that inside either the if or the else, both of them declared a new variable with the same name as a variable outside of that if statement. Everything that happened inside that if statement had no effect on the code. Like if I did val or var y here, anything that happens here has no effect on the output. This method always returns false, no matter what, unless it's an error. Like there are silly things like x can be null, and that'll be an error. But this if statement has no effect on the output for any valid input, any valid int. There's no lecture questions, but there's lecture objectives. Puck. So a little bit different. It's a different structure. I think it's going to work better. Time will tell.
Actually turns into this, which is a method call to the for each method.
And maybe the suggestion box would be more popular over time. I don't want to put too much effort into it if it's not going to gain traction naturally, though. I'm starting to think that students just don't want to make suggestions like that. You'd rather just have me prepare a review lecture. But I don't know.
So what you're seeing is the for each stack frame and the anonymous function stack frame.
Just me right here, background. What's happening in the background? Oh, is it this clicking? Is that what you're talking about? Or is there something else?
Don't worry about it.
Nope, there's actually audio. Oh, yeah.
To know about this, you don't have to think about this. We will talk about for each and
It's Twitch. Because I refreshed the page and Twitch autoplays. Thank you. Yeah, so it was whatever the default page was, probably. No, it should have been my channel, actually. It should have been a really horrible echo. Yeah, because I had it paused, but when I refreshed to see if the votes happened, that's where we got that running. I'm also clicking a pen. I gotta stop that. Yeah, Mike can edit it out. All right. So no questions about any of that. Everybody's good on 100% good on variable scoping, stack frames, running the debugger. I'll give more debugger examples. I'll give those whenever I can. The debugger is something that can save you many, many hours of your life and much, much frustration. When you have a bug, run that debugger, set a breakpoint, run that debugger. You're getting to the point where you got to start using these tools that are available. Your programs are going to get too big to just eyeball errors. They're too big to just show up to office hours, plomp down your code, and say fix it. Because it's going to take us a long time, and you're not going to be satisfied with our answers anyway. It's getting to be time where you can run the debugger, start taking advantage of these tools that are built into your IDE, and start getting rid of those bugs. Start saving yourself some time. With the debugger, you can get these projects done way quicker than without. You can see right away what some of your errors are. Think you're good with variable scoping? Good. How do you set a breakpoint? Right next to the line numbers, right to the right, click. And I'm just doing a left mouse click. And same thing to get rid of them. Can you go over stack memory? I just did that. Like a lot. If you have a specific stack memory question, I have a feeling you don't, because you are the professor, after all. All right, let me look at my cheat sheet. What else do I want to talk about? Interviews. Yeah. And time. Oh, shoot, that I spent a lot of time on that, didn't I? The next thing I want to talk about is something I did with this. With more time, I was going to give a live example. the real Jesse would never ask to go over stack memory. I would do a more live example, but I'll give the example through this scope example. So when I wrote these methods, what I did was what we call stubbing out methods. This is how I give the handouts to you when you download the paleblue.repository. All the methods look something like this: true, 0, like something like this. This returns an int. So what I'm doing is writing the method header, defining what the inputs and outputs are, and then just returning anything. In Scala, we can actually use this syntax as well to say, I haven't implemented this method yet. This method doesn't exist at the moment. But just my personal preference, I like to give some default value for what I'm returning. So when I first wrote these methods, factorial you can look at on your own time. I won't go through all of that. Factorial and permute. But this the ultimate goal of this method is to compute the permutation of x permute y. So I'm going to stub out all of these methods and not even have a main method. This is how this file looked when I was preparing this example. I wrote it exactly like this, where I have the method names, the inputs and outputs, and just some default return value that doesn't have any meaning. This is something you replace. Like when you write down to write a paleblue dot method, first thing you do is delete my default thing. I give a default just to avoid this error. It's saying, hey, you promised you would return an int, but you never returned an int. You didn't return anything, which is unit in this language. What's going on with that? And then you start writing your code, and you return whatever you're computing. One silly mistake I see, I guess not silly because you're still learning this stuff, but you write all your code. You write some beautiful code here, but you leave this 0 down at the bottom. And you compute a really beautiful answer, and you're trying to return it, but you end up leaving this here, and then you always return 0, no matter what you're computing. Another good thing that a debugger is going to be able to catch. So this is what my object looks like. All these methods stubbed out to do nothing, but I know what my methods are. I know what they take as an input. I know what they expect as output, and I know what their names are, so I know what they're supposed to be doing. Then I go to my testing, and I write the tests before writing the code. This was an interview question to get you thinking about this. That was an open-ended question. There really was no right or wrong answer, as long as you were giving us something thoughtful, some thoughtful response of what if you wrote your tests before your code? Well, this is actually a big thing. This is a big concept in computer science. Is it called early software engineering, called test-driven development. We write our test cases before we write the code. So when I write my test cases, like I have this is negative method that's going to tell me if the input is negative, it's going to return true. If it's positive, it's going to return false. And you can argue if 0 should be positive or negative. I'm calling it positive for my purposes. So that question messed you up. It was an open-ended, just give us your thoughts question. So I know what this method is supposed to do, and I can start writing my test cases, thinking about all the edge cases. So I know 0, 1, and -1 I want to test. I'm going to test a wide variety of inputs in between there. And I also want to test the max and min values of an integer, the absolute highest value positive number I can represent in an integer, and the absolute largest negative number that I can represent in an integer. So I want to test those endpoints to make sure that this method is working the way I want it to. Now, I don't know what my code is going to look like at this point. I just know that whatever I write, whatever implementation of is positive or is negative is it has to pass these test cases. This is the expected behavior of the method. And where this really comes in handy, and then I, of course, test it. Let me get to a trickier one. Let me get right to the permutation one. So the permutation, 1 permute 0 should be 1, 1 permute 1 should be 1, etc. And I have a good number of permutation test cases here. Where this comes in handy is it forces me to think about the expected output for particular inputs, which I actually had to look up. Like, what 1 permute 0, what does it mean to take 0 elements out of one element and then arrange them? How many ways can I arrange that? What does that actually mean? Should it be 0 because there's no actual outputs to have? Or should it be 1 because the only possible output is the empty set? It actually ends up being 1. So, but I had to look that up and think about what the expected behavior is on all these edge cases. What if we have negative? Actually, I don't do negative numbers here. Another one I actually looked up for factorial. What about a negative factorial? Negative 8 factorial, what should that be? And the internet and my calculator told me that it should be negative 8 factorial. Which I had the question, how about negative 3? Should this be negative 3 times negative 2 times negative 1, which would end up being positive 6? So when I have an odd value, should that be a positive output? I don't know. So I just searched around and decided. The internet told me. Actually, now that I say it, now that I think about it, I wonder if it had. Hey, let's find out together. Actually, it had 7 factorial and then just negated it. I'll have to add my parentheses and make sure. But if this is the expected behavior, then I know that going in when I write my method. So if I know that my test cases are solid, first I know my test cases are solid, so when I'm writing my method, I can run my test cases and then see if my code is correct on those test cases or not. But it also forces me to answer those questions beforehand. It's a lot easier to think about these questions when you're just focused on the testing than when you're focused on writing the code. Because when you're writing the code and you get to a point and you're like, oh, should that be negative or positive? You might write a whole for loop and a bunch of logic and then figure out you did it the wrong way. You got to back up. You got to rewrite your method. Or even worse, you write your method and then you get to your test cases. You write all these test cases and you realize that you're wrong on all the negative ones. Revisit your method, select a big chunk of code, hit the delete key, and start over. You don't want to get into a spot like that. So if you're thinking about your test cases first, with test-driven development, it forces you to really define what the expected behavior is of the method that you're going to write before you jump into the code head first. Especially with the objectives in the homework, where it's more complex than just factorial. I mean, factorial is pretty straightforward. But when it's finding the closest city to a lat long, like, what are the expected behaviors there? It really makes you think about what the edge cases are, what the question is even asking, and what the expected output is of your method, and annotate that, record it in your test cases and write your test cases before you write the method. If you go into the method first without fully understanding the question, you're just asking to waste time. And especially when I'm forcing you to write test cases anyway, try writing your test cases before you write your code. And I'd be willing to bet that it's going to help you in the long run. It's going to be less time spent on the homework in the long run.